Hi everyone, it's Mr. Zarzak, and in this edition of Physics Underground, we're going to be looking at the physics of accelerated motion of systems of objects. So let's get right to it. Alright, so what I have here is I have a 200 gram mass, that's 0.2 kilograms, okay, tethered by this string. This is a pulley here, so just a wheel, okay, to our hover puck. Now right now the hover puck is off, so there is friction with the hover puck. If I let it go, you can hear the drag on the table. So with the friction on, it's probably not so surprising that if I take and I simultaneously drop another 200 gram mass along with the hover puck, okay, that the dropped mass gets to the ground first. But the thing is even when I turn on the hover puck, it still has mass, so it still has inertia, which is resistance to acceleration or resistance to forces. Okay, so even with the friction eliminated, if I drop this 200 gram mass at the same time I release the hover puck, we're still going to see more acceleration out of the drop mass because it doesn't have this extra inertia of the hover puck. All right, here we go. 3, 2, 1, and drop. All right, pretty cool. Let's look at that in slow motion. Okay, so I have this feather, and it is tethered over to a string that runs over this pulley, which is just a wheel. Okay, and then this is our hover puck, which is currently turned off. See, if I slide it around, you can actually hear it dragging on the table. When I turn the hover puck on, what happens is a fan comes on and allows it to ride on a cushion of air. So it's not actually making contact, all right, with the surface of the table. So it's essentially it's floating above it, so no friction. And when I do this, if I let it go, you can see that the little pull of the weight of the feather is enough to cause it to accelerate. Not very much, okay, but definitely more than 0. And let me see if I can get it to go this way here. So I'll push the hover puck this way, it'll slow down, stop, and then get yanked back in the other direction. Okay, so if the direction of our motion is in the opposite direction of our acceleration, we'll see slowing down. And if the direction of our motion is in the same direction of our acceleration, we see speeding up. Pretty cool. Now, just for fun, I've switched this up and I have the feather and the hover puck connected. But now I'm going to hang the hover puck off the edge of the table. Okay, and I will drop it at the same time as this mass. And even though the hover puck has to drag the feather doesn't have a whole lot of inertia now, does it? So not much resistance there, so we're not going to see much of a change in acceleration from that of free fall if we let them go simultaneously. All right, so here we go. 3, 2, 1. All right, and let's look at it in slow motion as well.